GATE 2013 Civil Engineering Question 48. A propped cantilever made of a prismatic steel beam is subjected to a concentrated load P at midspan as shown. If load P equals 80 kN, find the reaction R corrected to 1 decimal place using elastic analysis. The relevant NPTEL reference has been listed. If we are given a propped cantilever beam, so let us assume this is the fixed end and the load is acting at a point which is at a distance of x from the fixed end. So the remaining length of the beam would be L minus x. Assuming the beam is propped at this end where a reaction of R is acting. If we need to find the deflection at the free end of the cantilever or the propped end, it will be equal to 0 because that end has been fixed. So trying to find the deflection, so what we do is we visualize the beam to bend in this manner. Assuming the load is acting at distance x from the fixed end. So it is known that in a cantilever the deflection at a distance x from the fixed end is given by px cube by 3ei. So this will be the deflection at this place. Let us call it delta 1. The remaining deflection can be found if the slope at this location is known and it is operated with the remaining length, that is L minus x. So for small deflection values, tan theta will be equal to theta. So tan theta here can be seen as delta 2 divided by L minus x. So delta 2 can be written as L minus x into theta, which can be expressed as L minus x into P x square by 2ei, which will be the slope at this point, that is A. So adding delta 1 and delta 2, we can get the total deflection of the beam at the free end. Here it can be seen that the load P is acting at the midpoint of the beam. So assuming the total length to be L, so this part would be L by 2 and this part would be L by 2. So now we need to assume the deflected shape of the beam, which will be like this. So the total deflection as seen in the previous slide will be equal to delta 1 plus delta 2. So delta can be written as delta 1, which will be the deflection at this point, which would be equal to P into L by 2 cube divided by 3ei, plus we should find the slope at the point at which the load is acting. Let us assume the point to be A. So the slope would be P into L by 2 whole square divided by 2ei, and this will be operated with the remaining length of the beam on the right hand side, that is L by 2. So the total deflection will be obtained as 5pl cube divided by 48ei. This deflection will be due to the P load. Now there will be an upward deflection due to R load, that will be equal to RL cube divided by 3ei. This is similar to a load acting at the free end of a cantilever beam. Due to the propped nature of this beam, delta P, that is the downward deflection, should be equal to the upward deflection. This signifies that the net deflection at the propped end should be 0. So comparing the two values, 5pl cube by 48ei, it should be equal to RL cube divided by 3ei. So the value of R would turn out to be 5p over 16. It is given in the problem statement that P is equal to 80 kilonewtons. So substituting the value of P here, that would be 5 by 16 into P, that is 80, we get the value of R as 25 kilonewtons. So the value of R using elastic analysis was obtained as 25 kilonewtons. The relevant NPTEL reference has been listed.